Today we are going to be working with radicals. We've done square roots, we've talked about radicals and radicands, but today we're going to look at different indices of radicals. So radicals that have a different index. This is the nth root of A. The nth root of A would give you the number that if you multiplied that number by itself n times would give you A. The nth root of A can also be written as A raised to the 1 over n. The nth root of A is written in radical form because that symbol is called a radical. In that radical, n is the index and A is the radicand. When you rewrite it in rational exponent notation, rational exponent basically means that your exponent is a fraction. When you rewrite it in rational exponent form, the index from the radical becomes the denominator of the fractional exponent. So numbers 1, 2, and 3, the directions say rewrite. It does not say evaluate. It doesn't say solve. It doesn't say compute. It just says rewrite. So these three are written in radical form. We need to rewrite them using rational exponents. We need to rewrite them with exponents that are fractions. So this would be 9 raised to the 1/5. So number 3 would be 36 raised to the 1/4. Do you see a problem with number 2? There's no index. Now, I don't want you to forget everything that you've learned up until now. What is this radical symbol? What does that radical symbol mean? Like before you knew it as a radical, it was a square root. So this is the square root of 15. That means the index is 2. If you don't see an index, that means it is a square root with an index of 2. So this is 15 raised to the 1/2. This is actually a really good way to prove to you why this rational exponent thing works. You all know that the square root of 16 is 4, right? So in your calculator, if you try 16 raised to the 0.5, because 0.5 is the same as 1/2, your calculator will tell you 4. Okay, the nth root of A. N is the index of the radical. They're just trying to get you used to that terminology, the nth root of A. The next examples rewrite using radical notation. So this time it's written with rational exponents. We need to rewrite it with radicals. So 18 raised to the 1/3 would be the 3rd root of 18. Number 5 is the 4th root of 8. I just passed out what's called a perfects chart. This is a chart that shows all of the perfect squares, all of the perfect, well not all, a group of the perfect squares, perfect cubes, perfect fourths, perfect fifths, and so on. This chart can be used in multiple ways. It can be used to find numbers like, what is 5 to the 3rd? So here's how you would use this chart to find 5 to the 3rd. Look at the root 5. Raise it to the 3rd by going over to the 3rds column. 5 to the 3rd is 125. So on your own, please find 4 to the 5th. 1024. 4 to the 5th is 1024. Now you can also use this backwards. If I want to know what number times itself 5 times is 32, what I'm looking for is the fifth root of 32. What is the fifth root of 32? Start in the fifths column. Here's 32. The fifth root of 32 is 2. So you can use this chart both forwards and backwards to evaluate something raised to an exponent, and also to undo that by finding the whatever root of a number. Back to our notes. Again, we are talking about the nth root of a. So when they talk about n, they're talking about the index. When they say a, they're talking about the radicand. If n is odd, a has one real nth root. For example, the third root of 8 is 2, because 2 times 2 times 2 is 8. The third root of -8, before, when we had radicals, we said we couldn't have negatives underneath, but that's because we were talking about square roots, and you can't do a number times itself and end up with a negative number. But if you're taking a number times itself 3 times, you can end up with a negative. If we take -2 times -2, that's +4. +4 times -2 is -8. So the cube root of -8 is then -2. So if you have an odd index, a third root, a fifth root, a seventh root, if your radicand is negative, your root is negative. If your radicand is positive, your root is positive. So cube root of 8 is 2, cube root of -8 is -2. If n is even, if you have something like the fourth root of 81. Look at your perfects chart at the fourth root of 81. What is the fourth root of 81? 3. That means 3 times 3 times 3 times 3 is 81. There's another way to get 81. -3, -3, -3, -3. There's 4 negatives. All of those negatives cancel out and still give you positive 81. So the fourth root of 81 is positive or -3. If your index is even, you have 2 real roots, both the positive and the negative. So if it's a square root, the square root of 16 is positive or -4. The fourth root of 81 is positive or -3. The sixth root of something would be positive or negative. Now, if your radicand is 0, so the fourth root of 0 is simply 0. There's one real root, and that root is 0. And that also brings up imaginary numbers. If you have the fourth root of -64, your answer is no real solutions. It would be a negative, or it would be an imaginary number. And in case you're all getting worried, we are not going to do imaginary numbers with these. Okay? So if you have an even index with a negative radicand, there are 0 real nth roots. It's only imaginary answers. Go back to your perfects chart. We're going to help you out remembering this. Above the even columns, the seconds, fourths, and sixth, I want you to write ± above those columns. So if you're using this chart to find, say, the sixth root of 64. So the sixth root of 64. Sixth column, find 64. The sixth root of 64 is 2. But because that comes from a ± column, the answer is positive or -2. So hopefully that ± will help you remember, if I'm taking the sixth root of something, it's ±. If I'm taking the fourth root of something, it's ±. If you're taking the third root of 27, if it's third root of positive 27, your answer is +3. If it's the third root of -27, your answer would be -3. Your positive negative would match whatever your radicand was. They are asking us to find the nth root of a, so keep in mind the nth root of a. They want n to be the index and a to be the radicand. So the fifth root of negative 32. I think we've actually already done this on the perfects chart. What is the fifth root of negative 32? On your perfects chart, go to the fifths column, find 32. Slide all the way over. It is 2. And since it's odd index, if it's the fifth root of negative 32, your answer is negative 2. So that's how to do this on the perfects chart. What about on your calculator? If you have a scientific calculator, you want to look for right above your caret button, there's a symbol that says x square root. It means the xth root. So you have to tell your calculator what you want that root to be. So on a scientific calculator, you would punch in 5, and then your second button, and then your exponent button. That gives you the xth root. And then you'd punch in negative 32 and hit enter. Should give you negative 2. If you have a graphing calculator like this one, again, you need to punch in what you want the root to be. So punch in 5 to tell it you want the fifth root. Then you punch your math button. There's tons of helpful things in your math button. When in doubt, check your math button. In your math button, the fifth option says the xth root. So you select option 5, and it puts that 5 that you punched in earlier into the index. So the fifth root of negative 32, and it tells you it's negative 2. So let's try the third root of 64. Try it on your calculator. Then I want you to look for it on the perfects chart. Okay, the third root of 64 is 4. Because it's an odd index, your positive, negative should match whatever your radicand is. So third root of positive 64 is positive 4. The next one, the fourth root of 16. Take a look at your perfects chart. Fourth root of 16, 2. And because it comes from a fourths column, an even column, your answer is positive or negative 2. If your index is even, your answer is positive or negative.